we shall derive equations that are applicable to projectile motion. In our previous video, we had explained what projectors are. In case you had missed that video, I'll encourage you, go look up that video, watch it to the end. If you had missed any of our previous videos as well, particularly the one where we derive equations that are applicable to uniformly accelerated motion on the horizontal plane, I'll encourage you, go look up that video as well, because some of the equations there, we are going to pick from them, modify them, and apply them to projectors. Also, if you've not clicked the follow button yet, I encourage you to do so. Encourage and tag those you know will benefit from our videos. Let's do it together. So here we have a sketch on the board here. The y-axis, the x-axis is there. Okay, this arrow here is the line of action for initial velocity u. You know it's a vector quantity, and it is inclined at angle theta to the horizontal. From here, where you have r here, this intersection here is the takeoff point for the projector. So it leaves at this point and then it lands at the plane of projection at this point. So the distance from takeoff point to landing point will be the horizontal range. We would also derive an equation for that. And at this point, you see these H marks. It is assumed that the object attains maximum height at this point. So we also derive equations for, or equation that will be applicable to help you calculate maximum height of a projector. Before then, let's recall from our previous video, we have that V equals to U minus GT. At maximum height, we want to see what happens at maximum height. At maximum height, certain things will apply. The object number one will be momentarily at rest. So what that means is that this V that stands for final velocity will be 0 at maximum height. That's what we are going to use. And also know that the component of U, initial velocity, in the vertical direction will be U sine theta. How do we do that? Just imagine holding the arrowhead and then pulling it this way so that the line of action of U runs parallel with the y-axis. Remember from our resolution of vectors, whenever you resolve a vector and then you open up the angle, because if you hold the arrowhead and then pull it this way, you are going to open up, make angle theta wider. When you open up and make it wider, when you are resolving, you know, any vector into a component direction, it becomes sine. But if you hold the arrowhead and then pull down, in other words, you close up theta. If you need to have the line of action of U run parallel with the x-axis, you are going to close up theta. That becomes cos theta. So we will substitute the vertical component of initial velocity here in this equation. Remember, the final or the maximum height, final speed is 0. So this becomes U sine theta minus GT. When you rearrange this, change of subject of formula, we can move this to the left. Minus U sine theta equals to minus GT. Remember, here it was positive. When it crosses, it becomes negative. We divide both sides by minus G, which is a coefficient of T. We have minus U sine theta divided by minus G equals minus GT divided by minus G. So minus G will cancel minus G. The negative signs will also drop off, leaving us with U sine theta equals to T. So if we rewrite this, we can say that T equals U sine theta. Rather, this should have been over G. Remember, there's a G here, over G. This is equation 1. This small letter T is the time taken for the projectile to get to maximum height, not the total time of flight. So what then will be the total time of flight? It's going to be double. Okay, the total time of flight, the time taken for the object to leave the plane of projection and return there, is going to be twice the time taken for it to attain maximum height. Again, this little letter T, small letter T, is the time taken to get to maximum height. So total time of flight, we can call that capital letter T equals to 2 small letter t. We substitute the values here, so we'll have 2u sine theta over g. So t equals to 2u sine theta over g. So this becomes equation 2. Have you seen that? In subsequent videos, we would look at equations 3 and equations 4. Okay, so feel free to drop your concerns in the comment section, and in case you've not clicked the follow button yet, do so before you go off. Encourage and tag friends, associates you know will benefit from our video. Thank you.